Well, here I am. Actually, I am at home over the weekend. Right now, if you're watching this on the actual class day, Thursday, I am getting ready to present what we've done in class with the lecture capture at a conference in Vail, Colorado. So, a little different way. Sorry I can't be there to interact with you, but we'll do the best we can presenting this material this way. And let me know tomorrow if you have any questions. So today's lesson is brought to you by the letter A. A, of course, is for algebra. And algebra we use to answer the question, what if? What if x is 10? What if x is 2? That's really the question here. What happens when that changes? So algebra allows us to answer what if. Before we start into too much algebra, let's take a look at some definitions. And when we talk about algebra, we talk about terms. We have variable terms and we have constant terms. A variable term is made up of a coefficient, and that's that number in front of the variable, and of course the variable. Together then, those make a term, and in particular they make a variable term. So this is a variable term. When we have a constant term, it's a constant because 3 doesn't change. 3 is always going to be 3. But the variable term 2x is going to change depending on the value of x. If x is 3, then that term is worth 6. If x is 4, then that would be 2 times 4, or 8. The constant term is just that. It's always going to be constant. Then we have what they call like terms or unlike terms. In like terms, each variable and its exponent must match exactly. But these factors do not, so they don't need to be in the same order. So they do not need to be in the same order. Okay, what's all that mean? Let's take a look. 3x squared plus 4x squared are like terms because the variable and the exponent match in both of those. They both have x's and they're both squared, and we are adding. We have a little different rules for multiplying and dividing. 3x squared and 3m squared are not like terms. And that's because the x and the m are different. They're different variables, so we can't add those or subtract them. They do have the same exponents, but we said that they must match variable and exponent. Common variable, common exponent to be able to add. Notice how we never did really talk about the coefficients. Those don't come into play when we're looking at like and unlike terms. It's just the variable and the exponent. So let's try a little quiz. Select the appropriate description. Are these alike or unalike? Remember our definition. We're looking for common variables with the same exponent. So these are alike. Oh, but you say they're in different order. Remember we talked about the order doesn't matter. This has an x squared. This has an x squared. This has a y squared. This term has a y squared. Because they're in different orders, it doesn't matter. And we know that their coefficients are different, but again, that doesn't come into play in our definition of like and unlike terms. And this is going to be really important as we go on to this section, because whether the terms are alike or unalike kind of helps us determine how we're going to combine those, or even if we can combine them. So how about r squared s and s squared r? Are they alike or unalike? And you have to ask, do they have common variables with the same exponent? So in this case, they are unalike because they both have an r, but this r is 1 and this r is 2. They both have an s, but this s is 1, this s is 2. So while we have common variables, we do not have common exponents. So if we're looking at combining, then we can only combine like terms. And notice how it says combine like terms to simplify. Meaning that we're going to make things hopefully simpler. So 2x plus 2y. What's that combined to? No, it's not 4xy. It combines only to 2x plus 2y. They are not like terms. They're not alike. So do not combine. How about 5y and 6y? Well, that's going to come, those are alike, right? Because I have the same variable and the same implied 1 exponent. So when I combine those, I get 11y's. This is just saying I have 5y's and I have 6y's for a total of 11y's. So think about that. If I have y times y times y times y times y, there's my 5y's, and I add to it y times y times y times y times y times y. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I have 11y's total. 5 times y plus 6 times y gives me 11y. So how about negative 3y plus 3 plus 2y minus 2? And here we have to find out what's alike. So think about our definition of like. They have to have the same variable, the same exponent. And in this case, our constants are alike, because really they just don't have a variable. So how about if I combine negative 3y and y? What do I get? I get negative 1y. We just add the coefficients and keep the variables, kind of like we did up here. We added 5y and 6y. 5 plus 6 was the 11, and we had the y. So now I have negative 3y, 2y, gives me a negative 1y. Combine your constants. That's really 3, a positive 3, and a negative 2. So what am I going to get? A positive 1. So my answer is negative 1y plus 1. So combining like terms to simplify these expressions. Evaluate each expression when x equals negative 2, y equals 5, and z equals negative 3. Remember, make your homes for the homeless numbers, and this is really going to be important here when we try and keep track of our negatives. So I've got z, x, and y, minus and a plus, and now I can put in my numbers. So z was negative 3, x was negative 2, and y is 5. They're all constants, so I can just combine them straight up. But what do I want to probably do with these two negatives here, this double negative? I probably want to change that to adding the opposite. That's going to help me bring these together. So all of it is plus now. So I have a negative 3 plus 2 plus 5. Working left to right, my negative 3 and positive 2 make a negative 1 plus 5. And I'm going to get what? A positive 4. Same rules we've had before with the integers. We've done things similar to this back in the prior chapters, but now we're using 3 variables. So in 22 here, we have x over y times z. Remember, there's an implied multiplication here. There is these two being multiplied. Some students have tried to write that as 50 negative 3. So kind of negative 53. Doesn't make any sense to do it that way. So when I substitute that in, I'm going to start by creating parentheses, find homes for the homeless numbers, and put in my values. So I'll have what? Negative 2 on top and a 5 times a negative 3 on the bottom. I simplify where I can, and the only one I can really simplify, the only one that I can really work right now is right here. So I'm going to make that into what? Negative 2 over negative 15 plus 31 over 30. But what's going to happen right here? What's going to happen right here to those two negatives? They're going to cancel out and become a positive. So I really have 2/15 over 31 over 30. Well, if I'm adding fractions, I have to have a common denominator. So my common denominator is 30. And to get that, I multiplied the 15 times 2, the 2 times 2, and I have 4 over 30 now, plus 31 over 30. So my answer is going to be, drum roll please, 35 over 30. But what do we always ask on our fraction answers? Can it be simplified? And yes, it can. In this case, we can divide both of those by 5. And we have what? 7 over 6. You can still write that as a mixed number also, 1 and 1/6. But remember, too, as we deal in algebra, a lot of times a reduced improper fraction is going to be easier to use. So try and get into the habit of writing your answers reduced and improper. Until we get into things like graphing, where mixed numbers really help, reduced improper fraction is a lot of times easier to use, because if you're going to multiply or divide the fraction, you have to change it back to improper anyway, so you might as well just leave it like that. So simplify each expression by combining like terms. So we have to find what's a like here. What are the like terms? Well, I have a c. It has an exponent of 1. 4c, sorry. I have a positive c and a negative 7c. So if I add those together, since they're all alike, notice how I get a 5c minus 7c. Now, I can change this to adding the opposite, or I can just think about this as a positive 5 and a negative 7, using this operation sign as the sign also on the coefficient. So if I have a positive 5 and a negative 7, I get what? Negative 2c. My variable is still c, so it's still right there. And what's alike here? Oh boy, we got a bunch of stuff. Well, we really just have 4 terms, and if you look at that, we notice that we have some x's, and we have some coefficients, some constants. Yeah, not coefficients, constants. So if I look at my x's, I have 1.7x and a minus 2.6x. Well, how do I add or subtract integers when I have a negative? I'm taking away more than I have, aren't I? So I know my answer is going to be negative. So I need to subtract and take the sign of the larger. Well, I know that my 2.6 is the larger. I'm going to subtract 1.7. And I know my answer is going to be negative because the 2.6 was negative. It was the larger value, the larger digits. Because remember, we're really thinking the absolute value here. So when I subtract this, I have to borrow 16, a 1. So I wind up with what? 0.9 negative. But what was the variable that was on there? Yeah, it was x, wasn't it? So 0.9 negative x, and then I have this 3.4 and 7.8. They're both positive, so I can just add them. 3.4, 7.8, and 2, carry a 1, 10, 11.2. So I have a positive 11.2 to put with that. And then what's that combined to be? Can I do any more combining on that? And no, I can't, because they're not like terms. Because this has the x, this has no variable to it, I have to stop right there. And yes, it seems funny. It seems like I should do more, but I can't. Because they're not like terms, I can't combine them any further. So don't be tempted to go any further. We're going to stop right there. Negative 0.9x plus 11.2. And what about fractions? Can we have fractions and as coefficients? We sure can, and we're going to do that quite often. So take a look at your grouping. We really have a negative 7/12x and a negative 3/10x. So let's rewrite just those two together. Negative 7/12 x minus 3/10 x. So that gives me those two together. But what do I know? What do I need to take care of these variables? Yeah, that's right. I'm going to need a common variable, a common denominator in here, aren't I? So yes, we have to have a common denominator. And what's the common denominator going to be here? Correct. That's going to be 60 as a common denominator. So my common denominator is 60. I'm going to be subtracting still. And what do I multiply times 10 to be 60? Multiply both of those by 6. So I have 18 now. Multiply by 5 on the other fraction. And I have a negative 35. And I still have my variable x in here. You can work either with the coefficients, or it's kind of handy to kind of keep that variable with you too, so you don't forget to write that. Both of these are negative now, meaning that I'm really going to add them together. I'm going more negative. So I have a negative, what? What's 35 plus 18? A negative 53 over 60. And x. Then I need to combine what? My constants. I have a 5/6 minus 1/3. What's my common denominator? Yeah, 6. And how do I do that? Multiply that by 2 to get 6, so I multiply the top times 2. So I have 2/6. This one stays the same, or you can consider it as multiplied by 1. And I'm going to have what as an answer then? Positive, because 5 minus 2 is a positive 3 over 6. And that's my answer, right? Well, no. Because we can do what to 3/6? Right. We can reduce that. So 3/6. Oops, sorry. Didn't reduce that. Divide both of those by 3. And I have what? 1 over 2 negative 53 over 60. So one of the keys there is to make sure that you've got everything reduced. So now let's look at multiplication. So So when we multiply, remember that there is a small little multiplication symbol right in the middle there. This really says -2 times 11y. And remember, the 11y is actually being multiplied. It's 11 times y. Because it's all multiplication, we can use the associative property to kind of regroup things for us. So we can think about that really as -2 times 11 times y. And then what's -2 times 11? Well, that's going to be -22 times y. So the -2 times the 11 gives us our -22. Signs are different, so the answer is going to be negative, and our y just carries on. So think about just multiplying the coefficients together and keeping the variable. So how about 3/4 times -8a? So again, we have these two numbers that we're going to be multiplying. This coefficient of -8 times 3/4, and we're just going to hang on to the a. So I really have 3/4 times -8 over 1 times a. So remember that parentheses is giving us our times. What do we notice about those fractions? Yeah, I can cross cancel. So 4 divided by 4 is 1. -8 divided by 4 is a -2. So there's nothing to cross cancel between the 3 and the 1. So I multiply straight across, and I'm going to get what? -6 over 1 times a. And we generally don't write that over 1. So we make that equal to -6 over a. So there you go. There's the lesson, 8.1. The first half of it. We'll continue on 8.1 on Friday when I get back. So if you've got some questions, then we will answer those tomorrow in class. So I know, this isn't necessarily the best way to teach you, but it allowed me to stay on track with the material and give you an insight into what we're going to be covering. So we shall see you tomorrow.